Welcome to the Mongoose Library channel. Today we'll be discussing SNTP. SNTP stands for Simple Network Time Protocol. It is used to get the current UTC time over the internet. A very common use case is when a microcontroller boots up and needs to connect to a cloud server over TLS. During the TLS handshake, the cloud server sends its certificate, which includes the start date and expiration date. If a microcontroller does not know the current time, it cannot verify the validity of the certificate, which poses a security risk. An easy way to solve this problem is to get the current time using SNTP. There are many public SNTP servers, such as timegoogle.com, timemicrosoft.com, timeapple.com, and so on. A microcontroller can choose which SNTP server to use, such as timegoogle.com. SNTP works over UDP port 123, so a microcontroller sends a UDP packet to timegoogle.com on port 123, containing an SNTP request, and SNTP server responds with the current time. Let's take a look at how it's done in practice. Get an STM32 development board, connect it to the workstation and then to Ethernet. Open your browser and go to Mongoose Wizard at mongoose.ws/wizard. On the settings page, disable all functionalities except for SNTP. Generate the firmware code, download it to the local directory, build it, and flash it to the microcontroller. Start the serial monitor, restart the board and check its IP address. Start Wireshark to observe network packets. Set the capture filter to port 123 to see only SNTP packets. Restart the board again, and you will be able to see the SNTP request and response in Wireshark. The request looks like this. It is generated by MG SNTP request function in Mongoose Library. It is a 48-byte packet, which consists mostly of zeros. The non-zeros values are the first byte, which indicates request flags, SNTP version 7 and client request indicator, and the last 8 bytes, which are two 32-bit values of what client thinks the current time is, in seconds and fractions of seconds. In our case, the current time reported by the microcontroller is the number of milliseconds since boot. The response looks like this. It gets parsed by the MG SNTP parse function, which performs the validity check. Then it extracts three 64-bit timestamps recorded by the server. The origin local timestamp is sent by us in the request. The receive timestamp indicates when the SNTP server received our request. And the transmit timestamp is when the SNTP server sent us a response. SNTP servers are typically fast, so the receive and transmit timestamps are often the same. Finally, we get the local current timestamp, the number of milliseconds since boot. We can calculate the overall network latency, which is the difference between current and origin local timestamps minus processing time. If we add half of the network latency to the transmit timestamp, we'll get the current UTC time. In the firmware code, we can catch this event by modifying mongoose glue.c file. Once the synchronization with SNTP is done, the mgnow function reports an accurate UTC timestamp in milliseconds. This is it for today. Thank you for listening and see you in the next one.